Well, hi everyone. Got a video here on simplifying monomials, and a monomial expression is in simplified form when, let's just make a list here. There are no powers of powers. Okay, you can go back and look at that property again, how we get it out of that. Each base appears exactly once. I'll capitalize that. Appears exactly once. All fractions are in simplest form. And we have converted, so there are no negative exponents. We've made a conversion. I'm going to make sure all four of these are the case when we do this. So let's do, I got 4 examples here. Example 1, we're going to simplify all these. 2x to the negative third y to the third times negative 7 x to the fifth y to the negative 6th. All right, well first I'm going to just kind of remove the parentheses and take the 2 times the negative 7 times the x to the negative third times the x to the fifth, just kind of rearranging all these terms, times y to the third times y to the negative 6th. These are coefficients. This is negative 14. X times x to the negative third times x to the fifth is x to the second. Negative 3 plus 5 is 2. And y to the third times y to the negative 6th is y to the negative third. Okay, there's no power of powers here. Each base appears exactly once. We have 1x and 1y. All fractions are in simplest form. This is just a whole or integer here. There's no negative exponents. So this is equal to negative 14 x to the second times 1 over y to the third, which I'm going to write as negative 14x to the second over y to the third. Now we have no negative exponents. All right. Example 2. Got 15c to the fifth d to the third over negative 3 c squared d to the 7th. Now when I do this, I like to kind of 15 over negative 3 times, you can split it up since it's all factored out like this, c to the fifth over c to the second times d to the third over d to the 7th. All right. I'll work down here. This is negative 5. This is a simple division. Now c to the fifth times c to the second, you subtract. 5 minus 2 is 3. And then we have 3 minus 7 for our power of d, and that's negative 4. And then that's negative 5 c to the third times 1 over d to the fourth, using the negative exponent property. which is negative 5c to the third over d to the fourth. Now, example 3. I've got a over 4 is being raised to the negative third power. Now, negative 3 and positive 3, those are kind of reciprocal powers. One of the things I can do here, I like to do this. I like to flip this fraction, take the reciprocal of a over 4, which is 4 over a, and make the negative 3 into positive 3. And then that is 4 to the third over a to the third. And if we have a number, 4 times 4 is 16 times 4 is 64. So 64 over a to the third power. For example 3. And let's do an example 4. I'm going to take negative 2, x to the third, y to the second, and I'm going to raise that to the fifth power. I'm going to take the negative 2 to the fifth power. I'm going to distribute this power. I'm going to take x to the third to the fifth power. I'm going to take y to the second to the fifth power. And this negative 2 to the fifth power, you can do that. That's negative 32. X to the third to the fifth, that's x to the 15th. Y to the second to the fifth, that's y to the 10th. I had to keep going because you're not allowed to have powers of powers, so we use that property. And there's no fractions. Each base is here once. X and y are here once. And there's no negative exponents. So that's what we have here, guys. Thank you.